Inverses of relations and functions. Our objective is to graph and recognize inverses of relations and functions, as well as find inverses of functions. Why learn this? Inverse functions can be used to find prices before taxes, discounts, and extra charges. Let's look at graphing inverse relations. Graph the relation and connect the points, then graph the inverse. Identify the domain and range of each relation. So when you're trying to graph inverse relations, start with your original table. To graph the inverse of that, simply switch your x and your y. So let's graph this first one, which would be the original function. So we've got 0, 2, 1, 4, 2, 5, 4, 6, and 8, 7 will be off of our grid. So we can connect these up. Okay? And now, to graph the inverse, we simply switch our x and y values. So now we've got 2, 0, 4, 1, 5, 2, 6, 4, and 7, 8 will be up here somewhere. So it'll be off of our grid. And then we can connect those ones up. Okay? So notice how when we have our grid, we even continue this line a little bit, as our 8 is going to be over here. Notice how it kind of reflects right over the y equals x. So that diagonal, that would kind of come right through here. Okay? So now we got to look at our domain and our range. So the domain is all the x values, and the range is all the y values. So let's look at our first one, the one in green. Your domain is going to be between 0, and then it stops at 8. And then our range goes between 2 and stops at 7. So between 2 and 7 for our range, and 0 and 8 for the domain. Well, now let's look at the other one. What happens to the domain and range? Well, if you switch your x and y, you're going to just switch your domain and range. So your domain becomes between 2 and 7, and your range becomes between 0 and 8. Functions that undo each other are called inverse functions. You can also find the inverse function by writing the original function with the x and y switched, and then simply solve for y. So just like when we made our table and we switched the x and y, to do this with functions, when you start with a function, simply switch your x and y and then solve for y. So let's practice. Use inverse operations to write the inverse of f of x equals 2x. Well, we talked about how f of x is like the same thing as saying y. So let's start by writing this as though it has a y. So we have y equals 2x. Now, because we want the inverse, we're going to switch our x and our y. So we're going to have x equals 2y, inverse. And now, solve for y. You want y by itself. So we're going to divide both sides by 2. So we end up with y equals x divided by 2. And to finish it off, so that way you can write it, so that way everybody knows, hey, this is the inverse function, you're going to have f inverse of x equals x over 2. So that way everybody knows that it's the inverse of your f of x function. Let's get a little bit more tricky. We're going to write inverses of multi-step functions. So we're going to use inverse operations to write the inverse of this function. So let's start by going, okay, well, y equals x divided by 4 minus 5. We want to switch our x and y. So now we have x equals y divided by 4 minus 5. Last step is to solve for y. So we're going to add 5 to both sides. That leaves us with x plus 5 equals y divided by 4. And now we're going to multiply both sides by 4. And that leaves you with 4 times x plus 5 equals y. Rewrite it just so that way everybody knows this is the inverse function. So we have f inverse of x is 4 times the quantity x plus 5. So now let's try writing and graphing inverse functions. We're going to graph f of x equals 3x plus 6, and then we're going to write and graph the inverse. So we start at 6, and then we go up 3 over 1, or we can go down 3 over 1. And then we connect them with a line. Now that we have our line for our original, we can now put together the information we need for our inverse. So we have y equals 3x plus 6. Let's switch our x and y. So we have x equals 3y plus 6. Subtract 6 from both sides. And then divide by 3. So we have 1/3 x minus 2 equals y. So we start at -2, and then we go up 1 over 3. Or we could go down 1 over 3. And connect them with a line. And there you have it. You've now graphed an inverse function. So to do so, as a recap here, we're just going to switch our x and y values, solve for y, and then graph that equation. Let's look at a retailing application. A clerk needs to price a digital camera returned by a customer. The customer paid a total of $103.14, which included a gift wrapping charge of $3 and 8% sales tax. What price should the clerk mark on the tag? So let's start by writing ourselves a function. So our cost here is going to equal. Now we've got 100% of it plus the 8% sales tax. So we have 1.08 times our price plus the $3 charge for wrapping. And now we can solve for P. So we have C equals 1.08P plus 3.24. All we did was distribute. Then we're going to subtract 3.24 from both sides. And then divide by $1.08. So we have C minus 3.24 over 1.08, and that equals our P. Since the total cost was $103.14, we're going to replace our C with that. So we have 103.14 minus 3.24 divided by 1.08, and that gives us 92.50. So this is the price the clerk should be putting on the digital camera. And that also ends our video lesson on inverses of relations and functions.